Okay, so now that we have identified in our last chapter a variety of different threats that could hurt our organization, we'll need to identify how exactly we are vulnerable to these threats. And we're going to assess where our weak points exist, um, and give ourselves some actionable information so that we can create better defenses. So, um, in this chapter, we're going to talk about identifying vulnerabilities, um, implementing penetration testing, and assessing vulnerabilities. So, first, we deal with host vulnerabilities. So, host systems on our network are mostly vulnerable through the software that they're running, right? The underlying operating system or platform, how the operating system is configured. The operating systems are going to come with default configurations. We need to make sure that our we're not just using default configurations because this is often insufficient. We're going to need customized configurations that meet our own unique needs. But this configuration that we create needs to be evaluated because if it's not evaluated, then it may become vulnerable to attacks that we weren't really prepared for as an organization. And these poorly configured hosts will end up opening our system up to another potential attack. So, for moving forward, um, failure to, well, in this example, really quick, failing to disable Telnet can lead to a man in the middle attack. So, Telnet allows us to connect to another computer. However, um, Telnet is insecure because there's no encryption there, and so somebody can sit in the middle, right, and read. So instead of using Telnet, we would use SSH. So when it comes to software vulnerabilities, and these weaknesses on our software come from a bunch of different factors. It could be errors in code. It could be that it wasn't designed for security. And so we're going to look at a couple of these major vulnerabilities that are a result of these mistakes here. So 0-day is the first one. So a 0-day vulnerability is one that a malicious user is able to exploit before the vulnerability is known by the public or even to the developers themselves. And because the developer doesn't know about it, they haven't had a chance to fix it. And so developers are unprepared for this. So that leads to a longer lasting, often magnified effect on our systems, right? Then we have improper input handling. So software is programmed to expect a certain type of input. This may be just a username and password, right? And then users sometimes enter uh, input that software doesn't really expect to receive. So this could cause issues with processing. So poorly handled input can give unauthorized users access to our machines using things like SQL injections, in which maybe we were looking for a username and password, but we got something like tick or 1 equals 1, right? And that would mean we might have added that into a password input part. And so basically what it's saying is give me a password or 1 is equal to 1. No, I would input my password or 1 is equal to 1. And so 1 is equal to 1 is always going to be true. So it might potentially give us somebody from the database, right? Their password. Because errors are inescapable in any complex software, we need to have error handling, right? So one mistake that a lot of times developers are going to make is very verbose errors, um, that they'll give the attacker information to exploit code, right? So in this class, we're going to look at some of these SQL injections, and you're going to get a good idea of some of these verbose errors. We might try to put in some sort of command, and then it um, gives me information saying that I entered in the wrong type of software. I mean, the wrong type of syntax, right? And so that uh, specifically it says the wrong type of SQL syntax. And in this case, it told me that I'm able to put in SQL here, whereas though I didn't know, I wouldn't have known that unless they had told me, right? And so now I can possibly exploit the system. Then we have resource exhaustion. So resource exhaustion is where software doesn't properly restrict access to resources that it needs, right? Maybe an attacker is able to consume a whole bunch of bandwidth or CPU time or processing power, and too much of this resource consumption is going to lead to crashes on our system or network. Then we have race conditions. Race conditions occur when the outcome of the execution process is depending on the order of the timing of certain events, right? So when events fail to execute in the order that we intended, it will cause software to crash, right? So in this case, like we want things to go in the order of 1, 2, 3, 4, 5. Well, what if that order comes out in 2, 4, 6, 1, or well, I didn't have a six in there, but like 2, 4, 3, 1, right? Well, that's all out of order, and so that might cause our software to crash. And then we have memory vulnerabilities. So when it comes to memory vulnerabilities, we could have memory leaks. So memory leaks occur when software doesn't free up its allocated memory when it's done using it, and this can lead to potential system instability. Those of you who've ever played SimCity, there's been a recent game that's kind of replaced SimCity as the city building simulator called Cities XL. And that game had a very serious memory leak that they never seemed to patch for, even years after the fact. And so the memory leak would cause the game to pretty much crash. It was unstable, right? Um, so anything you built ended up being garbage anyway, because of that. Anyway, so buffer overflows. This is this happens when data goes past the boundary of its assigned memory buffer and can corrupt adjacent memory. So we have basically like memory slots in our computer, right? So everything you do or save on a computer, it needs some memory to be used, right? And so um, sometimes maybe if you guys have ever run disk defragmenter, right? And it shows like little red lines all over the place on there. Well, that's because it was the storage in there or wherever things are saved, the memory is in different spots on the computer, right? And because of that, so basically those are slots of memory. So in some languages, we have to specifically say what where the memory is going to be, how much memory space is going to be there. Um, so somebody may assign something to be like, I don't know, a few hundred bits, and in a buffer overflow, this data is going to go past that few hundred bits and start to corrupt adjacent memory, right? So if you remember the disk fragmenter, kind of try to think of memory as like that, right? Because there's different, it has red, green, and blue lines, and it tries to um, prop when you run the disk defragmenter, it kind of tries to push everything together in one spot rather than it being all over your computer in different memory locations. And so that goes into what I'm about to talk next, which I'm going to go straight into pointer dereference. So we may be pointing your computer because there's things saved in different areas. It has a pointer that references to that certain area on the computer where something is saved, right? And so with a pointer dereference, we are no longer the computer is no longer pointing to that specific location on your computer or memory that that something that you needed was in, right? And so this will cause it to crash because there's nothing there or it's pointing to the wrong thing, right? So it's code that attempts to move the relationship between the pointer and the thing it points to, the point E, right? And so if the point E is not properly established, then it could crash or corrupt our memory. With an integer overflow, this is when the computed result is too large to fit in its assigned memory space. So this leads to a buffer overflow. So remember, maybe I allocate X amount of memory to whatever variable, but there's too much of it. So there we go. This possibly led to a buffer overflow. And then we have DLL injections. So this is when Windows applications attempt to force another running application to run a DLL, a dynamic link library, in its memory, and this can cause the application to crash or make it unstable or something like that, right? Encryption vulnerabilities. So some encryption solutions are insecure or become insecure over time due to efforts by attackers and researchers who try to break encryptions. So organizations end up using weak cipher suites after a while to secure their websites or their software because somebody's already found the answer, right? Or maybe you're just using an old one just because you haven't really thought about it, right? Uh, you're not up to date with current standards. Um, some encryption vulnerabilities come down to poor implementation. So we might have an organization that improperly configured the digital certificate, and we're going to talk about those a whole lot later. But in this case, maybe their digital certificate doesn't match the address that's on the actual domain name, right? Or maybe our certificate is expired, or or it's not formatted incorrectly. In any case, the client may not be able to fully trust that connection, and then it won't be able to establish an encrypted session because of that, because the certificate's not set up the correct way, and the certificate helps us to establish our encryption, right? Then we could have improper key management that leads to vulnerabilities. Um, Maybe your private keys weren't stored properly, and an unauthorized person, was able to access the keys, and now the unauthorized person can impersonate the victim, right? Or maybe they just perform a man-in-the-middle attack. Network architecture vulnerabilities. So the design of a network can reveal weaknesses for attackers to go ahead and exploit. So an attacker looking to gain entry into a network is going to search for the easiest pathway into that network. So if we place like a internet facing web server and a offline backend database in the same subnet without any separation, then it's going to be easy for for somebody to jump from the web server to that offline backend database, right? They might be able to move through the network into that database and extract that information, right? Another example of a vulnerable network architecture would be maybe a network whose physical coverage area isn't properly designed. So a lot of times wireless signals are going to leak beyond their office building into the surrounding property. So maybe somebody can sit out there across the street and receive the wireless signal without even being on the property, and then the attacker therefore is going to be in a better position to access the network. Um, Maybe other than gaining entry, attackers attempt to exploit vulnerabilities that lead to the denial of service. So if a network hasn't properly balanced its traffic, um, then an attacker could congest the network with a whole bunch of extra traffic, right? And then can lead to delays or denial of service, right? Account vulnerabilities. So attackers are always looking for a way to exploit the identity of of you as the user and of computers. So by getting at account vulnerabilities, they can bypass the authentication that we have or authorizations we've set. So there's a bunch of different ways that an account could be misconfigured, and that's going to lead to that bypass, right? So maybe you put in no password, or maybe your password was weak or didn't have the right amount of complexity or length. Maybe you have passwords that don't expire, right? And so maybe he's already gotten your password, and so the password doesn't expire. They can stay then there in your network indefinitely, right? Maybe you have accounts that are not using multi-factor authentication. Multi-factor authentication is going to give us another layer of defense, and we don't have that. Maybe your accounts are placed in the wrong groups, and so this will give accounts the wrong level of access. Maybe you have accounts that are given more privilege than they need, and we are supposed to be implementing the concept of least privilege here. Um, Maybe we have unused accounts that haven't been disabled or deleted. So that's a potential account that can be used. Same thing with guest accounts. We don't even need to just only focus on the technical side of that's vulnerable, because attackers are going to try to exploit vulnerable business processes in day-to-day operations anyway. And the biggest element of that is going to be the human target, right? Because we have a lot of untrained users, and they're going to be the largest target in any organization, because it's so easy for attackers to trick people into doing the malicious work for them, right? Users who aren't trained on how to spot social engineering attempts, or users that aren't maintaining minimal security um, hygiene or aspects, can be a threat to your entire organization, right? And so, we definitely need to train our users a lot, right? Um, Also, another level of weakness would be in having not planned out for critical business processes, right? So, an organization that doesn't plan for end of life (EOL) will end up with obsolete systems and won't have a way to transfer their responsibilities to a more secure system, right? Um, there could be organizations that don't really find themselves with the support from system vendors, because um, you didn't prepare for end of life, right? And embedded systems are particularly true, because they're a bit more difficult for um, people to understand. Like they're not these are designed specially, so they're not things that anybody can just walk up and start working on. Um, when it comes to end of life, I know a lot of MRI machines were using like Windows XP at one point, and so that was a big problem for Microsoft at the time when they tried to retire it, because these were critical systems for the medical community, and so they had to come up with a special plan for end of life, for vendor support and end of life operations. I believe they had to kind of extend what services they were going to offer specifically because of these medical devices, or that, or have these medical devices rendered vulnerable or obsolete. And then we have something called system sprawl. So when it comes to system sprawl, um, we could leave our system open to vulnerabilities because it's difficult for people to manage very large systems, right? And so, if we're unable to manage these systems, we can leave our organization vulnerable to compromise. So, without a specific process in place to ensure that all of our systems and assets are documented, it's going to be hard to address our security challenges, right? Because, hey, if we have undocumented assets, they can just walk away, right? So our first activity is going to be identifying vulnerabilities. You have been asked to assess Developtek's vulnerabilities. To begin, you are going to identify common vulnerabilities that could affect the business. So, in this scenario, we are going to answer a few quiz-based questions, a couple essay-based questions, and move forward to the next slide. Security assessments. So now that we know a few of these vulnerabilities, we're going to want to assess the vulnerabilities in our organization, right? So there are certain tools and techniques we can use to more quickly identify where our weak spots are, right? So a security assessment is going to be the process of testing security controls through um, a security assessment is going to be the process of testing security controls to expose any weaknesses or gaps in our tools, technologies, services, and operations. Right? So, the purpose of this testing is to provide us with information that we can use to mitigate any vulnerabilities in a timely manner, um, there are a wide variety of these methods, um, and these could be done actively or passively. And these methods are going to um, influence other characteristics of this assessment as well. When it comes to vulnerability assessments, this is one of the methods, right? So it's an evaluation of a system security based on the configuration of its state. So essentially, the vulnerability assessment is going to determine if a current configuration matches the ideal configuration. Vulnerability assessments are going to be accomplished through automated tools, right? That are going to look at the organization's systems, applications, devices, and see if they match up to the current state of effectiveness and security controls, right? And so this is going to identify any misconfigurations or lack of security control or hopefully other vulnerabilities. Security assessment techniques. So, some of these common techniques could be a baseline report, right? So, a baseline report is going to be a collection of security and configuration settings that are going to be applied to our particular network or system or organization. And this is our baseline, right? So, the baseline is the report against what we measure other systems to in our network. So, we create a baseline for a specific computer and then decide which settings we want to include and depend on to ensure its security. And these should follow industry recommendations, right? Um, Once we've done that, we can make sure we can look at all the other computers or systems in our network and make sure they adhere to this baseline. Next up, we have code reviews. So a code review needs to be conducted for all applications in development. So reviews can be done manually by developers, or we can use a tool to do it for us, right? An automated tool. And then both these methods are going to be pretty useful in identifying weaknesses. However, if we don't use them, uh, we can be attacked. So one of these things that we need to understand is how big is our attack surface, right? So our attack surface is going to be a combination of all the areas that are exposed to an attacker, all the paths an attacker can take um, to get into our system, right? So it's reducing the paths that allow an attacker to get into our system reduces the risk of successful attacks, right? We'll be less vulnerable. If they don't have enough roads to get in here, um, and we've have good defenses on the roads that do go in, then we are going to be um, a lot better off. And then we have review of security architecture. So a security architecture review is a security infrastructure model. It's an evaluation of that model, right? So we should have regular reviews to determine if our systems are up to date and that we have secured our critical assets. And during this review, we're going to look at areas of concern and target them, and then we will further evaluate this and make sure that our methods are up to our current needs, right? And then we need to review the security design. So security design reviews are going to be completed before we actually implement our security. And using the architectural review results, we can determine whether our security solution does actually meet our needs. When it comes to vulnerability assessment tools, um, we're going to use these tools to see what potential attackers would see if they were to access our systems. So its usefulness to us is going to depend on how well we can interpret the results of these vulnerability assessment tools. And so we need to understand them and be able to read the results, and that way it'll be easier for us to address any vulnerabilities, right? So we have several different assessment tools First up is the vulnerability scanner, and this is used to assess systems, networks, and applications for weaknesses. Then we have our port scanners. We've talked about that before, such as Nmap. So this assesses the current state of all ports on our networks. That way we can detect any open ports that may pose any potential risk to our organization. Following that, we have the protocol slash packet analyzer. We use this. This is something like Wireshark, right? This is going to be used to assess traffic on a network and reveal, and it's going to assess traffic on the network, and it's going to help us to reveal what contents are. A protocol analyzer, such as Wireshark, is going to assess traffic and what it reveals about the contents and protocols being used in our system, right? Then we have fingerprinting tools. These fingerprinting tools are going to help us identify operating system information and any running services on it. This is also called banner grabbing. There's something called a network enumerator, which helps us to map the logical structure of our network. And see, once we have mapped the logical structure of our network, we can identify rogue systems on the network because, hey, we know that we don't have 15 routers, right? We only have 10, right? So maybe they're not, we know that there are 5 rogue routers, access points on our system, right? Then we have password crackers. So password cracker is going to be used to recover any secret passwords from data stored or transmitted by our computer. Um, we have backup utilities that are going to create copies, and a honeypot. A honeypot is created to redirect suspicious activity from legitimate network resources and kind of isolate them somewhere else so we can watch what they're doing. So if we have a hacker come in, maybe we have something labeled company secrets and hope that they go to company secrets and go snoop around over there, right? Types of vulnerability scans. So there are a whole bunch of different vulnerability scans types, right? Some tools are geared towards scanning a wireless network for weak points, and some are used to see if we're in compliance with uh, security configuration standards. Some may even see if we align with the baseline that we've created, right? Um, so vulnerability scanners are considered in the context of credential scans, um, and non-credential scans. So a credential scan is gonna it's going to use specific permissions that are going to be set by our security personnel when they scan the system. It has elevated privileges in order to test all the areas of our system's configuration rather than just assessing what a normal user would have saw. So if we can get really thorough in checking out our system. However, this is going to be more intrusive. It's going to consume a lot more resources, right? And then we have a non-credential scan, which scans from a normal user perspective, a hacker's perspective, right? It's going to allow us to focus on the most glaring flaws that anybody can possibly exploit, um, and so that way it's less intrusive, it consumes less resources, and it specifically um, focuses on what is most likely to happen, right? False positives. So all scans are gonna have the possibility of giving us a false positive. So when it comes to our security assessment, a false positive is going to be something incorrectly identified by the scanner as being a vulnerability. And it doesn't actually have to be a vulnerability, right? It's important that we understand that we don't need to always act on a false positive, um, because that was a mistake and that could have significant impact on our systems because maybe we need some of these things to be open, right? For example, like we assume we have a vulnerability scan that is going to identify a specific port being open on the firewall. And because a certain brand of malware is known to use this port, the tool says that this is a security risk and it recommends that we close the port. However, maybe this port isn't even open on our system, right? And that costs us time and money, um, because we had a false positive thrown at the system, right? But we also don't want to disregard these entirely because then we can end up with other problems. Um, Maybe we actually want this port open on our system, right? We have our own specific need for this port being open, and it is a waste of time trying to close this port because this is something that we know we want to use, right? So we got to think about that. We also have something called a false negative. This is a tool that identifies something as not being a vulnerability, but it actually is a vulnerability. So in this case, we might have a vulnerability that goes undiscovered for a long time, and then there end up having a really bad things happen to us. So that would be a really bad failure on the scanning tools part, right? So we have several guidelines for assessing vulnerabilities. We should consider how our host operating system is going to be configured. We shouldn't really rely on default host configurations for optimal security because, hey, everybody knows the default and people have been found ways around whatever the default is set to. We should create custom host configurations that are going to reflect our security needs because, hey, each business is different and our needs are different. We need to consider how zero-day vulnerabilities in software can significantly increase the risk of an attack. Um, because hey, those zero-day vulnerabilities can take us completely down, if possible. So we may want to see how bad a zero-day vulnerability can affect us as an organization. We're going to want to consider how applications in our organization are susceptible to vulnerabilities, such as improper input handling, right? So we're going to want to test that out and see what happens, or maybe memory issues, right? We need to consider how using outdated cipher suites can compromise our network, right? A lot of if we're using a cipher suite that's been cracked 20 years ago, it's probably not very secure at all. Then we want to assess our digital certificates for misconfigurations, like invalid formatting, because if our certificates not working correctly, then we're not going to end up with encryption, right? We need to consider the impact of any weaknesses in our network architecture. It can make it easier for attackers to gain access to our um, network if it's improperly configured, right? We also want to consider the impact of misconfigured accounts because, hey, maybe somebody is able to access things that they shouldn't be allowed to. We're going to want to identify users in our organization who are going to be highly susceptible to social engineering, right? So, the maybe the lady at the front desk is very susceptible to social engineering and it's very trusting, right? And so maybe we want to make sure that she gets enough training to make sure that um, she's safe or he's safe, right? Then we're going to want to identify any critical business processes that lack a solid plan, such as end of life processes, because we want to continue on as a business. So we need to have plans in place to make sure we do so. And then we're going to want to consider the impact of system sprawl and undocumented assets, because we could have things out there that we don't have documented that have the ability to get into our system and that we didn't even know was there, right? The next activity will be capturing network data with Wireshark, and we're going to want to capture a baseline of normal network conditions. So once we've created a baseline, we can compare that to future traffic captures to this baseline. And then we're going to use Wireshark to do this, and we're going to filter out on SSL and TLS packets, which is encryption for our browsers. The next activity is scanning for general vulnerabilities. We're going to use Microsoft Baseline Security Analyzer, which is a vulnerability scanning tool, and it's going to scan our Windows server and make sure that we're up to date with standards on configurations. It's going to help us detect any changes and vulnerability over time, and it's also going to help us to keep track of any changes made to our system. Penetration testing. So vulnerability assessments are powerful tools for identifying weaknesses in our organization. However, we can also take an active role in finding vulnerabilities by using penetration testing. So penetration testing or pen tests are going to use active tools and security utilities to evaluate security by simulating attacks on those systems. So a penetration test is going to verify that the threat exists and then will actively test and bypass any security controls that are in place. So if authorized, because pen test has to be authorized in order to be legal, the penetration test will also exploit any other vulnerabilities on the system. Pen testing is less common and more intrusive than vulnerability scanning, and is and although information gained from a penetration test is more thorough, there's risk to suffering real damage to our systems. So people place tight restrictions on pen tests because we are um, actively giving access to somebody to hack our system in this case, basically, and we're going to want to control. So when it comes to penetration testing techniques, um, these are going to closely mirror what an attacker is going to do in a real life scenario, because the whole purpose of the pen test is to simulate an actual attack. So um, these aren't just actions that a pen tester might take. These are the actual phases in the process of exploitation. So the first technique is going to be reconnaissance. So the tester is going to try to gather as much information about the target as they can, and this is going to help them to get ready to craft their simulated attack, right? Um, and so the reconnaissance here, it can be active, meaning um, scanning for ports. Active is when we send information to a system and we're trying to receive information back from the system, right? Um, Passive is when we're collecting information, publicly available information, stuff like that, right? Um, Maybe we're going to target them from social engineering or something. Um, then it's the initial exploitation. So once the attacker has gathered all the information they can from their reconnaissance efforts, they're going to start exploiting the target. So maybe this might include gaining access to the entire network, gaining access to a particular host, maybe getting account credentials, um, as much as we can, right? And then we have an escalation of privilege. So after an attacker's gained access, they're going to try to acquire as many privileges as they can, so they have the most control over the system that they can. So a pen tester is going to see how much they can increase their privilege in order to do more damage to the system, right? Um, Pivoting. So pivoting is a once a attacker has compromised a host, then they pivot, right? Change direction to spread to other hosts, right? That may not have been accessible, right? Once they found their way in, they make it to their real target, or just make it to other targets, right? So, for example, if they're able to open up a command shell on a host, maybe they answer commands in the terminal that lets us see any other subnets that this host might be connected to, and then this is going to allow the tester to move from one network segment to another if they're already connected to it, right? And then finally, we have persistence. So persistence is the last phase. It's gonna once everything has been exploited and everything else, right? We're gonna want to maintain access to a system to continue to exploit the organization over a long period of time, right? So it's gaining a foothold in the network, a long-term foothold in the network. When it comes to testing methods, there are several different types of testing methods. Um, there are black box tests. So a black box test is when a tester is giving no specific information about the system at all, and so the tester might know what it is, but not how it does it. So we're going to require the tester is going to be required to perform reconnaissance um, in order to figure out how to get into the system and everything else, right? So this is going to be useful for organizations wanting to simulate a real external attacker, right? And then we have a gray box test. And so this gray box test is when the tester, the attacker, has partial knowledge of the internal system. Um, and it's going to require a partial reconnaissance on the tester's part. But this kind of is useful for simulating an insider threat. Maybe not a fully privileged insider because they do have to do some extra work on their own, but it's good for simulating an insider threat. And then we have a white box test. So a white box test is when the tester knows all the aspects about the system, understands its functions, knows the design of the system, um, and this is going to be done like as a follow up to the black box test at times, to fully evaluate any flaws that they found. So there's no reconnaissance here. However, they can also be used for simulating the behaviors of a privileged insider threat, right? Um, Also, on top of all of this, there's the aspect of time and money. Um, a black box test is going to take the longest and require the most resources. So because of that, it's going to be the most expensive for a company to for a company to get people to come in and do that for them. A white box test is not going to take that much because you've given them all the information they need to go ahead and try to get into a system. And a gray box test is going to be somewhere in between, right? Penetration testing tools. So in a penetration test, security personnel are going to use all the same tools that they did in a vulnerability assessment, right? Um, well, a lot of the same tools anyway. So there's also some more tools they can use. Some of this will be like exploitation frameworks, right? This might be Metasploit or something like that. So this is going to be used to create and deploy code to exploit systems. There's data sanitization tools, so they might want to just destroy your data, right? So this is going to securely erase data from a storage medium. There are steganography tools. This is gives the ability to hide data with another data. So maybe they hide a malicious code inside of a picture, right? There's social engineering tools. So maybe we have tools to test our users on social engineering tactics. Maybe this is just a quiz or something like that. And then we have stress testers. So a stress tester is going to test our system's ability to respond to um, massive overhead and network bandwidth. So we're testing to see just how many people we can try to have log into our network at the same time before it crashes. In addition to these, we should know about several command line tools. There are a bunch of command line tools that are going to actually be on the test. Um, and this is going to be ping. Ping is going to see if we can get a response from a host. So that you would type ping into the command line of the terminal, followed by the IP number, and see what type of response you get. We have trace route, trace route, whatever you want to call it. This is gonna see the direct route that your packet is gonna take to get to another system. So maybe Google.com. It's gonna show all the routers that it hits on its way to Google. Netstat is gonna tell us current connection information, like who we're connected to on a host. We could use something called TCP dump, and this is going to be used to analyze packets and protocols that come in. We'll see everything that's coming in our network, right? Um, we can use ARP. That's going to show us the address resolution protocol entries that are on our host. We have something called NSLOOKUP and also something called DIG. This gives us information about a particular DNS entry. Then we have ipconfig or ifconfig. That's going to give us information about our network interface cards, like maybe tell us our IP number and stuff like that. Nmap is going to let us scan ports. and also do fingerprinting on other networks. And then we have Netcat. So Netcat is going to help us to modify or monitor network traffic. I'll make sure that it's posted up somewhere that you can see all these command line tools in one place, so that way you can kind of try to remember them for when you take the test. So guidelines for when it comes to implementing penetration testing, we want to consider conducting a penetration test in addition to or instead of a vulnerability assessment, just to get a clear view of what people are able to do to our system, right? There the computer is only going to do what it's told to do, whereas though a human is going to try different things based on maybe experiences or hunches, etc. Right? Um, so it may figure out something that the computer doesn't, because computers only do exactly what we tell them to do. So if we're telling it to just scan, that's all it's going to do. Be aware of any risks involved in conducting a penetration test. This may be risk to your company because things can break when there's a penetration test because people are actively trying to break into a system. But there's also risks involved in being a pen tester. There's several pen testers that are currently facing court legal action just um, due to a pissing match basically between the state and local county government, because the state had asked that these people conduct pen tests on local county governments, but the local county government didn't agree to it, and they are pursuing legal action. So that's something you may want to be aware of if you go down the route of becoming a penetration tester. Consider implementing pen test techniques as different phases in a simulated attack. So that way we can kind of pretend like this is a real attack happening, and this is going to help us understand what would happen if it were to actually occur. Then we're going to consider conducting pen tests using different types of box methods. Remember, each different type of box method simulates a different type of attacker, as well as they can cost different amounts of money because of the nature of what's revealed to the pen testers themselves. Then we want to understand the different reconnaissance requirements for each box testing methods. Remember, black box testing requires the most reconnaissance. White box testing requires little to none. And then gray box testing is going to be in between. And then also become familiar with the tools used in exploitation of systems. So this includes, all those command line tools I just went over. This involves some of those vulnerability scanners that we went over. And then finally, we have the final activity for this chapter, which is going to be implementing penetration testing. We are going to want to conduct a pen test to see how attackers can exploit our systems. We've already cracked a weak password, in this case, used by the domain name James Emerson. So we're going to want to use these credentials in a simulated attack on our Windows server and use them to enable remote desktop access.